No, I can't.
I forgot what this is, and I'm kind of scared.
Yeah, she shouldn't be.
In honor of the squiggles, I need to start showing you guys my videos.
Yes.
Yeah, I agree.
Uh-oh. Just muted.
Sound is
You gotta start over.
Yeah, someone.
You asked for it. A whole page devoted to the rainbow sponge. Army Arts and Crafts Department sent me to Korea. Now, not a normal sponge. This is so dense. 3 sizes because I can't stand just one size. Another thing that I want to talk about is the hygiene of the sponge. I squeezed and squeezed and squeezed and squeezed. No flab on this arm for my cleaning. Flab on this arm. Now, if you do get it on your hands, gloves are incredible. I have a pure glove sponge that is absolutely pure. Oops, a virgin edge. Oh my gosh. Ah, I am sorry. Oh, I want you to look at all of those wiggles. Oh my gosh, wiggles. Oh my gosh. I love to wiggle the whole thing. There are many other surfaces that you can sponge on. I'm sure you would. Of course you can go straight. Oh my gosh. Oh, I love this. Are they incredible or what? Okay, calm down, Dee. And it's done. Yes, do you see that? Oh, earth tone. Look at that. Is this fun or what? Look at that. On a card. Breathing heavy. Oh. Oh. Yes. Yes. Still.
Just cover your eyes and
Oh my gosh. Now, think. Go this way. And now we think. Oh my gosh. Oh my gosh. Look at that time. Okay. And then. Oh, this was one night that I did not stop. It was so hard to stop.
All right, so the actual commercial is like an hour long, but that's the highlight.
Let's watch it.
That is the highlight. All right, so whenever I think of the squiggle for symmetry, that's what I think of.
Consolde?
Mr. Mack,
I find it funny.
it's the Spanish
I didn't leave my
squiggle. That's what it is.
I
forgot
to
tell you
And there's an eggshell on my car.
at the end of the day Monday,
Yes.
but my quiz is still in as a 0.
Yeah, I know. I am so behind on
John
stuff
Cena.
because I decided to let you guys turn in late work, which is the worst idea ever. Because the idea was, beginning of the semester, there's a few grades in. You guys, out of the goodness of my heart, I'll accept late grades. But by the time I actually get it done, because I'm so behind with everything else, rip in pieces. We have like more grades in now, so it wouldn't have mattered. But here I am,
Why are you ruining it?
plugging in stuff from a long time ago.
What'd you do?
I fixed it.
Oh, God, I think you made it worse. That makes me so sad.
I fixed it. All right, you guys ready? You guys ready? You guys ready?
No, I
You
don't
guys
like
ready?
squiggles.
Didn't we have
Why
one
not?
question yesterday?
Because the wiggles are
Yeah, you
better.
gave us a package.
Yeah.
I will not tolerate this wiggles versus squiggles racism.
Wiggles is.
All right,
I think there's like one store.
here we are. Number 3, which did we complete number 3 yesterday? Yes or no? Yes, we did. No, we did not. No, we did not. I left you guys some homework. All right, so let's talk about that.
Mr. Mack, can I have that?
Absolutely not.
Okay, good. I didn't want it anyway.
Oh my god.
Thanks, guys.
Here we go. I also have a couple more pages coming at you
We'll wait now.
very soon.
I love you.
So here we go.
That's kind of good.
I'll catch you up to where we were. For the people that were absent, as a lot of you guys are.
I didn't get that.
Weird balancing act of trying to push forward and also slow things down because everybody's sick. You were absent as well.
I don't know what it was about.
Chevy.
What?
Anybody else need one of these?
What did I do?
You guys actually had the fewest number of people gone yesterday, but all my other classes were
Where's
pretty much
Bailey?
empty. No, we're not getting pretty.
I'm a little concerned for her.
I'm not too concerned. It'll be okay.
She like
You want to throw
what if
me
she's, like,
any color
validated?
pen?
What if she passed out?
All right. C, D, E, A, all 90. So these were 90, we said yesterday. We wanted to prove that AD and BC when multiplied together, so in this segment times this segment, right? It's going to be the same as this segment's length times this segment's length, which is kind of wacky, right? Considering we don't know anything about the actual lengths. But here we go. So you guys said yesterday correctly that this angle right here was shared for both triangles, right? We have this triangle here that has angle A, and then of course the big triangle that also has angle A. What?
I need a pen.
We were concerned. So angle A is congruent to angle A, and we know that by shared angle.
Is this the times one?
Is it what?
Never mind.
Yes. Oh, I will zoom in
And I need a paper.
for the visually impaired.
Sorry.
All right, and I've got more coming. I just gotta hit print. All right, so then we said these two triangles are congruent, right? Or not congruent, they are similar by angle-angle similarity. This is not one of my pens. It's a 10.
Someone chew on it.
Gross.
You.
Oh my God, Taylor, no one asked. All right,
That was
so by
disgusting.
angle-angle, the two triangles are similar. So we're gonna write triangle ABC, which is a whole dumb big thing, right? And then we have the other triangle. A goes with A. B is this angle here, which means it must go with D on this triangle since they're similar. And then C is going to go with E. So we're going to say that they are similar. So Courtney, similar does not mean congruent. It just means that all their angles are the same and that their parts are proportional. So if this was like 2 in length and this was like 3 in length, maybe this could be 4 and then maybe this would be 6, right? They're all going to have a relationship times 2, times 3, times 5, whatever it is. It's going to relate the sides of the triangles, okay? So one triangle smaller, one triangle bigger, it's like blowing one up into the other, right? Kind of like a dilation. All right, so these two triangles are similar. Now that they're similar, we can say their parts are proportional, right? And so instead of CCP, which is corresponding congruent parts, we're going to have CSP, which is corresponding similar parts. So by CSP, we can say their parts are proportional. So what parts are proportional? Well, it looks like AB and AD are in the same relative spot, right? So I'm going to say AB over AD. And that's going to be the same relationship as BC has to DE. Is everybody following me on how I'm getting those letters? They're in the same relative location, AB and AD, right? BC and DE. And then first and third is AC. And then AE. Now again, be careful. If you're starting with the first triangle and writing that on top, make sure the first triangle's parts always go on top, right? You don't want to be mixing and matching those. All right, so these all relate. Now, how do I get it to look like this? Right? I've got an equation with all this stuff, which is good because that's what I need up here, right? But I want multiplication, not division. So I'm going to have to move some stuff around, right, by canceling division with multiplication. AD, BC, AB, and DE. So let's find out which parts of this equation we need. AD, BC, AB, and DE. So it looks like we just need this. And we're going to mess with that to get it to look like this. And that was your goal for homework. If you didn't do it for homework, or if you did do it for homework, great. What would you do?
I'm kidding. I was kidding.
I didn't hear you.
I said cross multiply, but I was kidding.
Did you do something different to your teeth?
What?
No. Cheryl's getting her braces off. I need to. Wait.
Multiply by the reciprocal.
You're not wrong.
All right, I'm back. Sorry.
What is that even
Yeah, what is that?
22 days left.
What would you do?
Just thought I'd update it.
We need AD and BC together on the same side with multiplication. What would you do?
AC and BC.
Yeah, together.
Oh. What? Division.
Division?
No,
No,
multiplication. You have
multiply
to
AB.
reverse by the reciprocal.
Yeah.
Oh wait, they're already being divided. My bad.
They're already together.
I'm about to start.
AD and BC are not on the same side. And they're also the division.
Just rewrite it so they're on the same side.
Yeah, pretty much. So what we're going to do is we're going to multiply by AD. When we do that, AD on this side divided by AD, right? They cancel. And when I multiply by AD over here, what we get is this. AB equals BC times AD over DE. Did everybody see how I got there? I multiplied by AD to both sides. So now I have a multiplication of AD here. And when I multiply by AD to this side, it gets rid of the division by AD, right? Because division and multiplication go away, right? They undo each other. They're inverses. So now I'm here. Everybody follow me there?
No.
If I had this, how would you solve a problem like Maria?
Multiply by 2.
You multiply both sides by 2. And when you did that, you would get x equals 10 over 9. But before you get there, you'd get something like this, 5 times 2 over 9, which of course would then be 10 over 9. So what we do is we multiply by the what's on the bottom to get rid of it, right? And move it over.
Why did we do AD?
We're going to do that. Why did we do AD?
Yeah.
Because we want BC and AD together, and I've already got that just now. But the problem is now they're being divided by DE, so I need to get rid of that, right? So what do I do when I have division and I want to get rid of it? So I'm going to multiply both sides by DE. When I do that, I get AB times DE on this side. And over here, I just get the BC times AD. Does that make sense? I'm dividing by something and dividing by something here. So if I multiply by AD to this side and multiply by DE to this side, I'll get AB times DE here, and I'll get BC times AD there. Again, if you want to get something on its own when it's being divided, all you have to do is multiply both sides by 2, like in this case over here. So what you get is this, because timesing by 2 and dividing by 2, right? Just 1, and anything times 1 is itself, so we get x. And we have 5 times 2 divided by 9, which is just 10 over 9. Right? That's the idea with like algebra, right? It's the same idea with this. I've got this. So I multiply by AD to both sides. That gets me AB. BC times AD divided by DE. To get rid of DE, I multiply by DE to both sides, so I get DE times AD over here, and then BC AD over here. Are we feeling okay with that? Yes, no, maybe? Ish? Okay. How do we feel about this? Not understand what's going on here either? Let's talk about this. Jerica, how do you feel about this?
I understand.
Okay.
That's fine.
So to get rid of the divides by 2, we times by 2, right? To get rid of the divides by AD, we times by AD. So we get rid of it, and we times by 2. Similar to how we times by 2 over here, right? Hannah?
I'm confused, like how that connects to the problem.
This?
No, the other. Like, why are we doing that?
So we want to prove that AD times BC equals AB times DE. And if you look, you've got AD and BC,
Oh,
right?
okay.
And AB and DE. We just have to rearrange it now a little bit, right? So this is making sense over here? Okay. The connection to this then is that when we want to get rid of divides by something, we times, right? So I wanted to get rid of divides by AD to move it over, right? And now I want to get rid of divides by DE, so I move it over by multiplication as well.
So, oh, okay.
Better? Can I help anybody else with this stuff? Once you see it, I think it's like, oh, of course, but until you see it, right, it's kind of hard. And I think part of that is because we have all these capital letters here. You're not used to multiplying all that stuff. Are you feeling okay? For real? Okay.
Wait.
Yeah?
When you're doing when you multiply by AD, why doesn't it multiply the DE too? It only multiplies the top part.
So that's a good question. So when I multiply by 2 over here, right, it gets rid of this. And it only multiplies the top because it's 2 over 1, right? Does that make sense? We multiply across. When I teach algebra, which is unfortunate you guys did not have me for algebra, and it's not because you had a different teacher that sucked or something, I'm not saying that. I'm just saying that like the way I teach it, I think, makes intuitive sense, and a lot of people don't teach it that way. Multiplication is done on the top, division is done on the bottom. Fractions are just division. That's all it is. 5 over 9 just means 5 divided by 9. You can do multiplication and division in any order you want. So 5 times 2 divided by 9 is just 5 times 2 divided by 9. That's it. Any order you want. Multiplication happens on top, division happens on the bottom. Okay? Are we feeling okay about that? Okay, cool. So now we've got this, and we want it to look just like that. Well, by the reflexive property, I am allowed to do this and just flip these around, right? And commutative property allows me to switch multiplication, right? 2 times 3 is the same thing as 3 times 2. So BC times AD is the same thing as AD times BC. All I did is flip it. So if I had something like this, x plus 2 equals 5, I think you would agree that I would be allowed to write it like this as well, right? 5 equals x plus 2. Right? So I'm allowed to do that. I don't need you to give reasons for why you're allowed to do that. It's reflexive property and then commutative property, but no one cares. Okay? How do we feel about that concept? Okay. When you see something like this, multiplication, right? Odds are you're going to get similar triangles, get a proportional statement like this, and then work it from there. It's a very common thing. Congruent triangles are cool and everything, because it's like, oh look, they're the same. But being the same is kind of boring. When you find similar triangles, you can learn cool properties. Like, look, if I times this by BC, those two lengths, no matter what they are, they'll always end up being the same thing as AB times DE. So if I know, okay, this is why this is useful. If I know that AD is 3, and I know that BC is, I don't know, 4, and I know that AB, this whole thing right here, is 6, I can figure out what DE is by using this property. So because the triangles are similar, I know that AD times BC should be the same thing as AB times DE. So AD is 3, right? You guys all see that? Sort of, maybe, kind of. I'm going to zoom out a little bit. So AD is 3. BC is over here. That's 4. AB is 6. So now we can solve for DE, right? Does everybody see where I got those numbers from? I just threw that on the diagram to show you why this could be useful, right? Okay. Not part of the original problem. So 3 times 4 is 12. And 6 times DE should also equal 12, right? So if we divide by 6 to both sides, we get 12 divided by 6, which is, of course, 2. That means DE is 2. So before, right, it looks like we have not enough information to really figure out what's going on here. But using similar triangles, we can prove that that has to be 2, this length right here, which is kind of neat. You could use this property to find the height of a triangle. So for instance, imagine that DE was scooted over, so it was going from here all the way straight down to 90, right? We'd have 2 similar triangles, just like we had before. And if we knew all the sides, we could actually use this to figure out the height. So if I were to give you a triangle like this, and I said, find the area, you'd be like, well, I know area is base times height, right, divided by 2. Well, the problem is you don't know the height, right? Well, you could figure that out by dropping a line right here. Heights are always 90 degrees. And then using this property to prove that the triangles are similar, and then if they're similar, be able to figure out what this height is, and then use that to find the area. Something like that. So similar triangles are going to help us develop a lot of different formulas and test a lot of things about triangles that maybe seemed unintuitive. I feel like when we did congruency, a lot of you guys are like, they look similar, or they look like the same angle, so they should be, and like 9 times out of 10 you were right at the end of the day, but you had to like prove it to get there, right? And it was like, why do I have to prove this? It's obvious, it's sitting right there. I feel like when we get into similar triangles, things like this are far less obvious, right? And it gives you some interesting results. So we had to get through kind of the obvious stuff. Why do I have to prove this? Oh my God. So we could get to this and really understand what's going on, and then we can find out cool stuff. So for instance, when we talk about cool stuff, let's look at number 4. Before I do that, I want you guys to figure out, like, try it on your own for a little bit and mark stuff from the diagram. I'll be back in just a second. I've got a couple more pages I'm printing out. I'm printing out a little bit at a time so it's not that overwhelming you guys. Also, with sick people being gone, if they're gone for a day and they ask for homework to, be like sent home for them, when they get like a 10-page packet, they kind of freak out. So I'm doing bit by bit. According to this, to freak out what she's asking.
I already took it that day, so. retake it that same day. Because
Also, for those of you interested in retaking the last quiz, I do have the version 2 made.
Wait, are we gonna have a quiz this Friday?
I'm sorry?
Are we gonna have a quiz this Friday?
Yes, that is to be over this stuff. Okay? Which, on the one hand, is different, so it makes it difficult, right? Because you haven't learned it before. But on the other hand, there's a lot, no pun intended, that's similar with what we've been doing, right? There's
I
some
have a
similar
question.
concepts. Yes.
not about this.
Okay, good.
Do you have an estimate of when the retakes will be in?
Estimate?
Because I'm failing this class.
Yikes. I don't know.
Or also, could you put it in as like a C while you wait so that I don't? Because I'm pretty sure it's.
That's cute. That's cute. That's cute. That's cute. Today I don't have game club or anything after school, so I should be able to use like, assuming I don't get swamped with people needing help, which I have recently, because you guys are like, I want to retake all my quizzes, which is great and adorable and wonderful instead of waiting to the end of the semester. But now, like every day after school, I've been here for like from like 3 to 5:30 at least, helping people, which is fine. But then I go home and I make dinner and it's like 7 o'clock and I'm like, oh my god, I'm tired. So I guess I'll grade all these retakes people did and all the late homework. And I get like some of it done and then I fall asleep. So I'm sorry.
I just need one more.
Which is why I know. And it's so simple to put it in, but I have to like get to it. So what I'm going to do is I'm going to try and prioritize the easier stuff to get in, that way I can get as much done as possible.
What's the easier stuff?
The easier stuff is like warm-ups, homework, all that stuff, right? I know, and then people hate me for that, but it's like, I can't win. I try to do it the fair way, I'll just start from the top and go on through, but
Let's
everyone...
just give up all worksheets.
Is there a way to put the quiz in as missing instead of 0?
No, I'm not doing that. Alright, I'll leave that.
Why am I connected to the Wi-Fi? It's just messy.
Alright. If and when we finish this one, I've got 2 more for you. So this is where results start getting a little interesting. So before I even mark up my diagram, let's talk about what this means. When we prove this, it's saying that BF, this part right here, compares to DF, right? These 2 little bits, the same way that AF compares to FE. So what and the comparison is 2. So what that means is that BF is twice as big as FD. Always, guaranteed. And all we know about these segments is that this is a midpoint, so these 2 are congruent, and this is a midpoint. Not even that the 2 sides are equal. This isn't an isosceles triangle necessarily. It's just as long as those 2 are the midpoint, if you draw a line from a vertex to the midpoint, vertex to midpoint here, when they intersect, they cut themselves into 2 to 1 ratio, meaning that if that's 6, this will be 3. If that's 8, this will be 4.
Wait, how do we know that?
That's what we're going to prove.
Oh.
So it turns out when you draw from the vertex to a midpoint, like this, and where they intersect, we can prove that every time, no matter what, it'll always cut this line into 2/3 and 1/3, meaning that if this was 6, this would be 3, right? Half of that. If this was 8, then this would be 4. Guaranteed all the time, no matter what, for any triangle. Yeah. So this is a pretty cool result. We're going to actually talk about this next week and what this is and what these special kind of segments are called. We're proving a theorem about them right now, actually. This is a theorem. All right, so we have this information. Let's get to it. We want to prove that triangles are similar. Which ones? Well, the ones that contain BF and DF and AF and FE. So the stuff that contains these 2 lines, right? So we're probably going to want to prove this big triangle similar to this big triangle. Same thing here and here. Yeah.
Can you do vertical angles here?
We can get a bunch of angles in here. So let's start with that. So let's just write down a bunch. We've got vertical angles here. We've got vertical angles here, right? We've got DFE. And that's going to be congruent. Angle AFB. Same principle for these angles here. Angle AFD is congruent to angle BFE. Okay, so that's good. Remember the things that we have to prove similarity are side angle side similarity, angle angle, so we only need two matching angle similarity, and then proportional sides, all three sides being proportional. Yes?
Can you do a shared side with the triangle on top and the triangle that's upside down?
The triangle on top and the triangle that's upside down, yes, they do share that side there. That is true. That is true. So you could mark it like this. We are going to be marking a lot of information that's not going to end up being useful, but that's okay. That's how we're supposed to do these things. DE congruent to DE. We're just kind of experimenting right now to see what happens. What else do you see? Yeah. This line and this line? If we could, that'd be huge, right? But we don't have the information to do that. In order to prove parallel, we need to do cap but backwards, so the converse, right? Normally, if these guys are parallel, then this angle here and this angle here would be the same, right? So if we can prove the reverse of that, like if I can prove that angle is the same as that angle, then by cap converse, then those two are parallel. That could be useful. What else do you guys see? Yeah, we could do that to figure out a lot of stuff. Like this, these all are going to add up to 180, right? That's all good. But it's not going to tell us that it's connecting to any other angles, right? It's just going to say, look, whatever those are, they add up to 180. And whatever these are, they're going to add up to 180. Are they the same angles? I don't know, but they're going to add up to 180, right? Here's something I think you guys are missing out. We have a shared angle at the top. The triangle here shares an angle with this triangle here, right? So by shared angle, angle C is congruent to angle C. Okay, now hear me out. When we talk about sides for similarity, we don't mean they have to be congruent, right? Angles have to be congruent, right? They have to be the same angles, matching angles is what we want, right? That's what AA means, right? But the sides don't have to be congruent, they just have to be proportional, meaning that they have a ratio between them that's the same. So check out CD. Isn't it half of AC? Right? Isn't EC half of BC? So the sides are proportional. We have a set of sides that are proportional to these sets of sides. The sets of sides in this triangle are proportional to the sets of sides in this big triangle. So I'm going to write that CD is proportional to AC. So again, here's what I'm talking about. This right here is proportional to AC. Okay? They relate. In the same way, let me get an equal sign out here. In the same way that CE, again talking about the small triangle at the top, is proportional to the big side of the big triangle, BC. Are you guys with me on that? Okay. So, how are they proportional? Well, whatever CD is, isn't it half of AC? Right? So if this were 1, what would this be? It'd be 2, right? So CD, if it were 1, AC would be 2. Does that make sense? If it were 3, what would AC be? 6. Now, you're like, how do I know it's 1 over 2 and not something else? Well, if it's 3, then it's 6. What does 3 over 6 reduce to? A half, right? No matter what these are, it could be pi and double pi, right? It'll end up reducing to 1 over 2, right? Does that make sense? No matter what these are, if it's 5 and 10, 6 and 12, pi and double pi, right? It's going to be 1 to 2 ratio. Does that make sense? It reduces to 1 over 2. So we can say that. So now we've proven 2 pairs of sides that are similar, right? They're proportional. We have two pairs of sides that are proportional to these pairs of sides, right? And we have matching angle in between. So we have side, angle, side, side, angle, side, similarity. Again, the sides aren't the same. This side is smaller than this side, right? But they are proportional, right? Both the green sides are proportional in the same way as the red sides. So we have side and side, and then we have an angle in between that they share. Are you smelling what I'm stepping? Not at all. Okay. When we did stuff before, we would say, look, that side matches that side matches that side. So we have two sides that match, right? Two pairs of sides. Now we're talking about similarity. We aren't talking about congruency. So we don't want them to match. We want them to be proportional. So this side is half of this side. Do we agree? And this side, whatever it is half of this side. So if this is half of that and that's half of that, then they're proportional. Right? And I can show that by writing this. CD over AC, right, the whole thing, will relate the same way that CE does to BC. Both are half, right? Does that make sense? Okay. So they relate to as a half, yes.
So that means both sides are congruent, right? Of the triangle?
No, we don't know that these are congruent. This could be 10 and that could be 12.
Okay.
And that would make this 5 and that would be 6, right? And that's okay. We're not proving congruency. We don't want them to be the same necessarily. We want them to be proportional. 5 relates to 10 the same way 6 does to 12. It's okay they're different numbers, because at the end of the day, 5 over 10, 6 over 12 is a half, right? No matter what these actually are, they're going to relate the same way. This guy is half of this guy. Are we digging that? Okay. So here's the thing. Now we can say by side, angle, side, similarity. Triangle ABC, that's the huge triangle, right, is similar to the small triangle. So ABC, A is made up of the green side, right, and then an unknown side. Green and our unknown, which is orange in this case, right, is this angle here. So A goes with D. B is made up of red side and unknown side. If I go here, red side and our unknown side, right, the orange side, is angle E. And C goes with itself, of course, right, because it's made up of the green and the red, green and red, right? You feeling okay about this, like 25%, 30%? Not even? Courtney?
Oh, younger than me?
Yeah.
I don't know.
Okay. It's a lot. So these two triangles are similar, this triangle and this triangle. Now, we know that now that they're similar, we can say, instead of corresponding congruent parts, CCP, we can say corresponding similar parts, which means angles will be equal and sides will be proportional. So check this out. By CSP, corresponding similar parts, I know that angle A, let's call it CAB, because we have lots of angles. Angle CAB. Okay, CAB on the big triangle, CAB. Do you see how CAB is third, first, second? Are we good with that? Third, first, second, right? Should be congruent to third, first, second over here. So angle CDE. So let's find that on our diagram. Is everybody cool with third, first, second idea, that concept? You guys see it? All right, so CAB, that's this angle here, is going to be congruent to CDE. CDE is this angle. So Bailey, you should be getting a little excited about this. We've just proven those two angles are the same, so we've got cap, right? Which means we can now say those two lines are parallel, so that's kind of cool, right? What? And then we have double angle saying that they're going to be similar as well, right? We've already proven this similar and that similar, right? So once we get one of these things, we did this to begin with, it kind of opens up everything else, right? That's the beauty of CCP and CSP. So we know those. Now by the same logic, right, this angle over here should be the same as this angle here, right? Because look, this angle is CBA. So if I go CBA, that's third, second, first, right? We're just reading it backwards. Should be congruent to CED, CED. So also by CSP, we have angle CBA congruent to angle CED. How do you feel about that concept?
I don't get how we know they're congruent if it just says similar.
Okay, so remember, in similar triangles, the angles are all the same, but the sides are proportional, right? So angles are the same, sides will be proportional. Okay? Okay. So now we're here. Last thing I want to show you, okay? If the sides are proportional, right, we know green here gets doubled, right? Red here gets doubled. So what should orange do? If green goes from here on this triangle to being doubled on the big triangle, and red goes from here to being doubled on the big triangle, what's orange going to do? It's going to get doubled. So here's how I'm going to show that. I'm going to put a point right here. I'm going to call it M for midpoint. And then I'm going to mark it like this. Does that make sense? Calvin?
I'm confused on what the CSP.
I'll talk about it in just a second. That's a good question. So let M be the midpoint of AB by CSP. AM is congruent to BM. Okay, so CSP, remember CCP, right? If the triangles are congruent, then their parts are congruent. That makes sense, right? CSP is saying if the triangles are similar, which we proved they are, right? The small triangle and the big triangle, then their angles should be congruent and their sides should be proportional. So sides proportional, right? Angles congruent. And we can do that. Remember CCP, we checked the order of the letters? CSP is the same way. See how I have CAB, third, first, second, right? Then it should be congruent to third, first, second over here. Third, first, second, CDE. What are those angles? CAB, this guy. CDE, this guy. So I use the order of the letters to figure out what's congruent. Does that make sense? Remember, angles are congruent for similar triangles, right? But sides are proportional. So then I said, same logic with CSP. If the sides are proportional, see how green gets doubled in the big triangle, right? And red gets doubled? That means orange must get doubled. How do I know that DE goes with AB? Well, if I look, DE is in second and third position, right? And AB is in second and third position. So those two sides are proportional. One is double of the other. Are you smelling what I'm stepping? This is weird, this is different. We haven't done this. But the idea is that angles will be congruent if we're talking about similar triangles. Does everybody get that? Angles are congruent if we're talking about similar triangles. Yeah?
Can you say CSP one more time?
Corresponding similar parts.
Yeah, like what does it mean?
It means, just like CCP, if we prove the triangles are similar, right? Because it's similar parts, right? If we prove them similar, then angles will be congruent and parts will be proportional. So angles, like CAB, will be the same as CDE, right? We're checking the letters, right?
Why did you change it to CAP when you did CSP?
So I was interested in matching up which angles here with angles down here, right? So I looked CDE, so I wrote CDE, right? That's first, or third, first, second, right? So it has to be congruent to third, first, second over here, CAB. Right? Does that make sense? So that's how I knew what angles went with what. I could also check up here. This angle is made of green and orange. This angle is made of green and orange, right? So they would go together. Again, if we write things carefully, we can do that. That's what CSP and CCP allow us to do. For CCP, parts are congruent, right? For CSP, parts are similar, meaning that angles will be congruent and parts will be proportional. So I said angles congruent. Everybody good with the idea of angles being congruent with CSP? Okay. Parts will also be proportional, meaning that if this guy's half of this and this guy's half of this will be half of this. So I cut it in half and I said these guys are the same as that. This is double whatever that is. Cool. All right, so we've got a ton of information on here. What we're going to show next is that BF, this part right here, is going to be proportional to DF. So what we're going to show is that this triangle right here is similar to this triangle down here. Something like that, okay? That's what we're gonna do. I think we're pretty much out of time. We got a little bit. All right. All right. I don't want this. All right. So. I think I want to stop for today.
Oh, thank goodness.
I think I want to stop.
Why? Mr. Mac?
Yeah. Bailey.
No
Bailey.
way.
All right. Today Wednesday.
Something like that. Alright, I'm about to make it in the bucket.
You can get it. Whoa, nice job. Again, like, whatever you want. Yes.
Something like that. Regionals is at the end of February.
Our regionals is Tuesday.
I don't want this.
We'll still have games next week.
Ew, I was on the live. That's gross.
It's okay, personalities are rude.
My personality is I've like just her personality is that she's a cheerleader. And she changed a lot of my shit.
Why?
Well, I
What's your guys' regional
This one,
Oh,
Like your character personalities in the play?
shit. That harsh.
I don't have a personality.
We don't have
You so smart. We're doing our best.
and that's on video number class. I'm getting sick. My hands are aching.
You need to make up a backstory for your characters. Really detailed and thorough. You need to have all your motivations laid out, and you need to constantly harass your director with like
Talk
talking
to the
about.
doctor in this one. You can come back.
Wow, hacky sack with me.
You can't, you're gonna. When I got my first pair of pants, my dad was like, no, you're fluent on hacky sack.
Wait, what?
When I got my first pair of pants, my dad was like,
I like your dad.
and then he bought me a hacky sack. Cherry or hacky sack.
You are a hacky sack.
One of those little skateboards that you can surf
I'm pretty sure.
I don't know what it is.
I like those.
Oh, I'm never gonna really do it
I
again.
also miss when they put marbles homies in your meals. My backpack was loaded.
Stop.
What if he landed on?
Remember when Ellie did that for the first time and you gave him a band-aid?
She knows what you're saying.
Yeah, he has a band-aid and it has really heavy jacket.
It says JJHK.
I know. I do. Friday food.
No.
I don't even
I
have
think we might be
sex.
set.
Okay, so maybe we actually were in a relationship. We were all parents of
Give
Jimmy.
me first, give me a letter.
Maybe that's
I think she liked it.
What if her poster was Oregon?
Kimberly.
Well, it's my sister.
I wasn't going to. We just say something I can't say. JD's been happy with
Name's
Harry.
Miranda.
For Kobe.
JD's still tanking.
Give me Randy.
Aiden said that if I ever search for Kobe, this is gonna
Maybe I should go to work.
obviously you did.
I really don't know. The only person to call her by her actual name is my mom.
and Christy.
Stop!
Otherwise we call
Someone
Jenny,
say-
Jennifer, and we call her Jenny or Jen.
What,
And
do you and
then
Aiden picture?
Kim,
The picture of mine.
I can't find others.
Me.
I know how he looks.
So
So
Dude, Justice really.
Literally.
short names.
That picture of Jack and Eric has more chemistry than.
we call Brandy Brandy.
What the heck? Oh my gosh.
No.
Why is that?
It was
It
just
was
not-
at 7:30 last
It
night.
has my
It was unable to be
Eric's
brought out
Eric's
of
like,
it.
take a
And
picture
they
of
should
I
completely
do not
did.
have
He died at 8:50
Yeah, but they
when he was
I
wrecked.
only have two
Even
over
though he's here.
I only have,
say.
I put 3 and
physically I only have 2.
No, you do not.
Yes, I do.
You do not.
I'm just teaching what's like in the real world.
Because Jenny is the only one that's
That
really
has anything to do with diabetes.
I don't only technically have one.
This is my second one.
Are you gonna fall asleep now?
because I only have 1.
Spike Jam. Like that's so right. You know how I posted this
If
on
I bear
Instagram?
it,
Jimmy's been through a lot.
You let it hit that corner.
Christy
I
got the
didn't
worst.
Look at that, Seth. Look what you made me do. Justice.
No, I'm taking it all my stuff.
Oh no.
It's cold.
Because
Can I have
he
that
goes,
cold?
what's with the thing in your story?
Why'd you break this?
I was like,
Sorry.
I just like it 10, 11, 12 hours.
I get 9 to that. That's what I
Not on a school night.
Dude, I literally wake up at 7:05. I wake up at 6:50 and I go to bed at 9.
Alright, cool. I'll see you then.
But we have basketball.